Hi, I'm going to do a quick video on the chain rule with trig functions. So here we go. We have, this is chapter 2.4, it's page 138. A few derivatives and functions to look at when we're dealing with trig functions. We've got the sine of u is equal to the cosine of u times the derivative of u. So again, chain rule is we take the inside or the outside, we take the derivative of the outside, and then we multiply that by the derivative of the inside. So cosine of u is equal to negative sine of u times u prime. Tangent of u is equal to secant squared of u times u prime. Cotangent of u is equal to negative cosecant squared of u times u prime. And secant of u is secant u times the tangent of u times u prime. And finally, we have cosecant of u is equal to negative cosecant of u times the cotangent of u times the u prime. What you hopefully notice is that in each case, the u stays the same the first time around, then we take the derivative of that piece. Okay? So let's look at another quick situation. This is where we might see sine squared of u. We can always rewrite that as sine of u to the second power, all in parentheses. Now, when we go to take the derivative of that, or we might have some sine of u to the nth power, and then it's the sine of u, or some other trig function where we could see cosine in here, tangent in here, any of the other trig functions. I just chose to use sine in this particular case as an example. But any sine of u to some nth power, what we do then, the derivative of that, so the derivative of this of dx is equal to n, bring the n value down, times the sine of u, which is the same piece on the inside, didn't change it, times n minus 1 to the n minus 1 power, times d dx, or the sine of the inside piece, so the sine of u, and finally, then we take u prime. Okay, so we'll look at those in the next video a little bit more in depth. Right now I want to do some basic trig examples here of not u substitution, but the chain rule with trig. So we have, let's say we want the derivative with respect to x of 1/2 sine of 2x. Now I've underlined this part in green. The 1/2 is a constant, so it stays the same. Now I want to take the derivative of sine of 2x. Well, the derivative of sine is cosine, so that changes to cosine. Again, we keep the middle or the inside part the same. And then we have to take the derivative of this part, which of the 2x, which is 2. Okay? So your final answer, then our 2's can cancel. And we're left with cosine of 2x. Example number 2. The derivative with respect to x of tangent of 3x squared. The derivative, so again, we have the green and the blue. I take the derivative of the tangent, which is secant squared, and we keep the inside piece the same, 3x squared, times the derivative of 3x squared, which is 6x. We move the 6x out front, and we get 6x times the secant of 3x squared. All right, another couple examples. Example number 3. We have the secant of 4x. We want to take the derivative of the secant of 4x. The derivative of secant is secant x tan x. Again, the inside stays the same, and then we have to multiply it by the inside, or the derivative of the inside, which is 4. So we'll get an answer of 4 secant to the 4x tangent 4x. All right, one final example, number 4 here. We have the cosine of x squared minus 2x. We want to find the derivative of that. So again, the green is the whole function. We're going to take the derivative of the outside function, which is negative sine x squared minus 2x. Again, the inside stays the same, times the derivative of the inside, which x squared minus 2x, the derivative of that is 2x minus 2, which gives us an answer of negative 2x minus 2 times the sine of x squared minus 2x. All right. I hope you had a great time with that, and please review that and see if you have anything else. Talk to you soon.